Okay, so welcome to our chapter on polynomials, chapter 5 in your textbook. Basically what I'm going to try and do in this one is I'm going to shorten the video because it was pretty well laid out. So this is going to be a longer video because I'm going to do the entire chapter, not just individual sections. If you do have any problems with any of the individual sections, just let me know in the messages, let me know in an email, and I can still do further exploration into each of the sections. By doing it like this also, like I said, longer video, feel free just to watch the sections you need. I'm going to give you a quick layout of how I'm going to run through this, just so you know when you want to slide that bar and fast forward what you're going to be looking at. So 5.1 is the first one, it's just multiplying polynomials. I'm going to look at this example here. So I have a binomial times a binomial times a binomial, subtracting a binomial times a binomial. And this is going to cover a lot of multiplying polynomials in one shot, because this is going to turn into a trinomial times a binomial, which is in there. Subtracting another binomial times a binomial, which some people have an issue with. So that will be included in this example as well. So it's going to be a longer example, but it covers a lot. For 5.2, we will look at just one quick example of factoring just to get a feel for it. That gets covered repeatedly in 5.3, 5.4. When I do get to 5.3, I think I'm going to do, as it stands right now, I have 4 questions planned out. So I'm going to work through 4 examples. And I will number them 1, 2, 3, 4. So then if you're looking for the 5.4 examples, I'll do a couple there. Then just so you have a guideline of how far to fast forward. Okay, so let's jump straight into this here and just get things rolling. I'm going to start with erasing what I wrote here. And we are just going to look at these examples. So what do I do if I have a binomial times a binomial times a binomial? What if I have to do some subtraction of terms in here as well? So that's what we're going to look at. First thing I'm going to do here is I am just going to take this a piece at a time. I'm going to make this longer than it needs to be, so again, beware of that. So I have a binomial times a binomial times a binomial, and I cannot do this all 3 at once, right? I can do 1, 2, 3. I can take the first 2 times each other, collect that answer. I'm going to put it all in brackets, keep it in brackets, and then multiply it through the next one, which is what I'm going to have to do. Otherwise, I might multiply too much. The example I'll give here is if I have 2 times 3 times 4, right? I can take 2 times 3 is 6, and then I have that times 4, and that equals 24. Because what some people try to do with their, not with this multiplication, but with their binomial multiplication, is when they have 2 times 3 times 4, I can't take the 2 times 3 is 6 and 2 times 4 is 8, and I get 6 times 8, which is 48. That is going to be the wrong answer, because I used the 2 and I multiplied the 2 through twice, so I'm getting double the answer. So that's why we're going to have to do this in the method we're going to. We will have to do the first 2, store them in brackets, and then multiply them through the third one. In the meantime, what I'm going to do is I'm just going to carry down the second section here, the second term, the x plus 6, x minus 7. I'm going to carry that down through, and then I'm going to show a shortcut for measuring, for multiplying. So stay with me for that one. So I'm going to start with our x plus 2 times x plus 3. I know I'm keeping the sidebar. I'm going to put a big square bracket. So this is going to turn into I have to take the x times the x plus 3, and now I also have to take the 2 times x plus 3. I have to find all of that answer, and I still have to multiply it through the 2x minus 4. And just for carry through, that's going to stick with me. Okay, so now I can work through this. So I have x times x plus 3 is x squared, x times plus 3x, 2 times x plus 3, so that's 2x plus 6. Whoops, there shouldn't be an x there. And that's going to be that chunk there. That's all going to be times 2x minus 4. And again, times, we'll look at this after. now I can carry this through, or I can collect my like terms now. Just to make it easier, I'm going to collect my like terms now, turn this into x squared plus 5x plus 6 times 2x minus 4 minus x plus 6. So this is when I'm going to have a trinomial times, it doesn't matter if it's a monomial, binomial, trinomial, whatever it is. I have to make sure that every term multiplies through every other term in the other set of brackets. So I can break this into 3 sections. I'm going to take this to x squared times 2x minus 4, plus 5x times 2x minus 4, plus 6 times 2x minus 4 to make sure it gets spread through everything. So I will write just that. So x squared times 2x minus 4 plus 5x times 2x minus 4 plus 6 times 2x minus 4. And in the end, I'm still going to need this guy over here. So again, I have this written out the long way, but at least if I do this the long way, writing it out, I'm not going to miss anything. So then it's x squared times 2x is 2x cubed. X squared times negative 4 minus 4x squared. 5x times 2x is 10x squared. 5x times negative 4 is minus 20x. 6 times 2x is plus 12x. 6 times negative 4 is minus 24. So now what I can do is, I'm going to be running out of room here. You can probably see I'm writing smaller and smaller. So again, I can got all of these terms here, which I can combine, but I also have to subtract x plus 6 times x plus 7. So yes, there's pluses and minuses in here, but they're all sandwiched together by these brackets and multiplication. So I have to subtract all of what this is. So what I'm going to do now is I will, just for purpose of space, is I'm going to change the color and write this in red. So I have to subtract everything that x plus 6 times x minus 7 is. So the other way I can do this without writing the x times x minus 7 plus 6 times x minus 7, I can just work through this by what they call foiling. And I'm just going to draw a line. I'm going to need the x, right? F stands for multiply the firsts. So the x times the x gives me an x squared. The x times the negative 7, right? So the outsides of both of these. So I'm going to multiply that, is going to give me negative 7x. I for FOIL is the inside, so now I got to take the 6 times the x plus 6x, and I'm going to have to take the lasts. So the last in each bracket, 6 times negative 7, is going to be negative 42. So without doing the extra step of stretching it out, I can still multiply by FOILing. The one thing I didn't do here, which you really got to start doing it right away, just so you don't lose it, is I have to subtract everything here. It's x plus 6 times x minus 7. I need to keep that in brackets. I haven't worked with the subtraction yet. I'm still working with the x plus 6 times x minus 7. And that's going to have a huge impact in our next step. So as I go here to my next step, so 2x cubed minus 4x squared plus 10x squared minus 20x plus 12x minus 24. So I have to subtract this term. So I have to subtract everything in here, right? I have to subtract the x squared. I have to subtract the negative 7x. How do I subtract a negative? You add. I have to subtract the 6x, and I have to subtract the negative 42, which means I have to add 42. So now I have all the pieces to get this together. Now, some of those who've had math with me in the past, so now I have to combine like terms. The way I always did this to help myself, and I've taught my other students this, and I can see it still shows up once, is I look at the degree to see, and I underline based on the degree of the variable, so I know which ones to join. This is an x cubed, degree of 3, so 1, 2, 3 underlines. This is an x squared, so 2. This is an x squared, so it gets 2. This is just one variable x, single variable x. This is a constant value, so I don't have to underline it at all. This is a degree of 2, so that exponent of 2 says underline it twice. 1x there, 1 power of 1 there, and another constant. Now, to write this in proper form, we write it from the highest degree to the lowest degree, and I need to collect like terms. So doing this gave me a nice little shortcut. So I need everything that's underlined the most first can combine, so the 2x cubed can combine with anything else that's been underlined 3 times. There's nothing else, so 2x cubed. Now I need to go to my next degree is 2, so anything that's underlined twice I can join together. So negative 4x squared, 10x squared, negative x squared. So negative 4 plus 10 is 6, minus 1 is 5, so plus 5x squared. I took care of all of those. Now everything underlined once. Negative 20x plus 12x plus 7x. So 12 and 7 is 19, negative 20, so that's going to be minus x. And then my constants, things that weren't underlined at all, a negative 24 and a plus 42, which would give me a plus 18. So that is one huge multiplying polynomial example, but at least that covered a lot of rules in one shot. If you made it through that with me, fantastic. Again, if you still need help, if you want me to do any of these individually, smaller, simpler, I can just send a request, and I can do just a binomial times a binomial. I can do just some subtraction, like whatever you need. Make sure you contact and message me. So at this point, I will pause the video. I will do a quick question on factoring, and we'll keep moving. Okay, so we are going to move on now with factoring. So this is going to be a quick, short lesson based on 5.2 in your textbook. Before I do move on with that, I just think I should do a heads up. When I was collecting my like terms on the previous question, apparently I had made a mistake. The final answer for that one should have been 2x cubed plus 5x squared minus 7x plus 18. I had this just as minus x in my answer in the last question. Apparently when I was collecting like terms, I missed negative 6x in my collection. So just be aware, yes, mistakes happen. Just do your work slowly, carefully. I was trying to get through all that video in one shot, and I made a simple mistake because of that. So take your time, work through slowly, because one small mistake, especially if it's at the beginning of a problem, is going to lead to you have to completely redo that problem. So make sure you're not making your life worse by trying to do too quickly. Okay, there's my little warning there. So I'm going to take a quick look here now at factoring. So if I need to factor 16x cubed plus 12x squared, so there's a couple things we're going to do here. Is we need to find out what is the greatest common factor of these two terms. So that's what I'm going to do first off, is I'm going to look for what are the prime factors. So I'm going to stretch these out as much as I can, use that to find the common factors, and then I can find that common factor to finish this question. Be known, you won't have to do this repeatedly. This is just a section to give us an understanding of how the factoring works and to give us a direction to go if we do run into struggles. But again, for this one, as you get through the math, this will get easier. The shortcuts will just pop into your head, and that's even better. But looking at 16x cubed, so if I want to look for the prime factors of this, I don't know if I maybe I'll switch back to my blue here. So 16x cubed, my prime factors are going to be, well, 2 times 2 times 2, right? So I can take 2 times 2 times 2 times 2. Those are my prime factors. 3x's, so times x times x times x. Do the same thing for 12x squared. So my prime factors are going to be, if I broke this down, it would be 2 times 2 times 3. And I have 2x's, so times x times x. So now if I'm looking for a common factor, and at that point the greatest common factor, what am I going to do here? Well, I just got to look for what do they have in common. So there's a 2 here and a 2 here. That's it for values, numbers that they have in common. So it's going to be a 2 from each of these. So my greatest common factor will be 2 times 2. They have 1x in common, two x's in common, so I can go times x times x. That is going to be the common factor. So the greatest common factor, of course, combine these is going to be 2 times 2 is 4, x times x is x squared. There, armed with that knowledge now, I can properly factor the 16x cubed plus 12x squared by doing just that. I'm going to need to divide 4x squared out of there. So 4x squared, and this is the way I do this using my head, is how do I take the 4x squared, my greatest common factor, how would I get back to the original, right? 4 times 4 would give me back to 16. X squared times x would give me back to x cubed. And 4 times 3 would get me back to 12. And I don't need an x because I got both of those there. So 4x squared times 4x plus 3. And I have successfully factored this problem. If I was to remultiply this again, 4x squared times 4x, 16x cubed. 4x squared plus times 3 is going to give me back to 12x squared. These two are in fact equal. So that's a quick look at factoring. So now let's take a quick pause, or I will pause anyways, and then I'm going to look at a couple quick examples of how to factor a trinomial, and we'll go through there. Okay, here we are in the factoring trinomials section. This is going to be the real meat and potatoes. This is very important, especially as you continue with math. Factoring comes up often, so this is very handy. It's nice to learn a few tricks along the way to help you out. There are a couple different methods we could use to do this. I try to teach others in class, but again, when I'm learning something new, I just teach me one way. Once I start to get that, or if I'm not getting it all, then teach me the other way. So again, if you're really stumped, let me know. I can try and find the other methods for you and show you. The other thing when we're factoring trinomials is we need to make sure we are in the correct form of general form, right? Highest degree first, so the biggest exponent first. So 2x squared plus 5x plus 3, right? That's general form of ax squared plus bx plus c. Again, these a, b, c values all carry weight with them. There's formulas where we use them, so we need to be in the correct order. So if I was asked what's the a, b, c value of this example here, my a value is 2, my b value is 5, my c value is 3. So make sure you're in correct order, otherwise again it won't work. Anyways, let's jump straight to factoring these. So I have 2x squared plus 5x plus 3, and I need to factor these, and it's going to end up becoming a binomial times a binomial, which means I'm going to need 4 terms and 4 total, so I can break it into 2 and 2, and I have 3 terms here. So I'm going to need to break this bx into 2 pieces to make this work properly. What 2 pieces do I break it into? Well, that's where we just use an old trick here. I like doing this because I like to see the numbers compared to each other. I'm going to just take my 2 and my 3. So my a value and my c value, I'm going to multiply them to make a value of 6. I'm going to make a list of all my factors of 6, which will be 1 and 6, or 2 and 3, or 3 and 2, but that's the same thing and written up there, so I don't need it. So I need to take my value of 6. So I'm looking for the 2 numbers that multiply to make 6, but add to make 5. So I'm looking at the 1 and 6 make 7, 2 and 3 make 5. Well, those 2 are the ones that I need to break the 5x into, the 2 and the 3. So this will become 2x squared plus 2x plus 3x plus 3. Again, if you look at here, I put the equal sign. Are these two the same? Yes, they're the same value, only one was split apart. As I'm working through this, now that I want to start looking at breaking this into a binomial and a binomial, so I'm going to look at these as the first 2 terms individually, the last 2 terms individually. So 2x squared plus 2x, 3x plus 3, and I want to pull the greatest common factor out of each of these. I will know if I'm doing this correctly because the results of after pulling out the greatest common factor, what's left behind should be the same for both pairs. So 2x squared and 2x, well, it turns out that 2x is my greatest common factor. So 2x times x will get me back to 2x squared. 2x times 1 will get me back to 2x. So this is broken down into 2x times x plus 1 for those first two. Now I got to find the greatest common factor between 3x and 3, which is just 3. What does that leave me with factoring wise? So 3 times x plus 1. So again, I have these two brackets are the same. I must have done this correctly. So now I can show this as, right, combine this as 2x plus 3 times x plus 1. And that is my answer for this question. I've factored this successfully. If you're not 100% sure, well, you can multiply these two together to make sure you get the same answer. And luckily enough for us, if we were to take 2x plus 3 times x plus 1, we were taught to break it into 2x times x plus 1 and 3 times x plus 1, which is what I have written above. We were taught to then multiply these through, so 2x times x is a 2x squared, 2x times 1 is 2x, 3 times x is 3x, 3 times 1 is 3. That's what I have written above. And when I collect like terms, that's what I have written above. So basically, multiplying and factoring are the complete opposite of each other. Multiplying means taking those two and mashing them together, multiplying it through. Factoring means taking this final answer and breaking it apart into two equal pieces. So that works out very handily. The one next example I'm going to look at here is, well, you know what, I'm going to release the board, reset, and then we can take a look at this a little more slowly. So I'm going to look at one more example where the a value is greater than 1, sorry, and then we'll go back and look at the shortcuts. Okay, so this is going to be the second example of 4 and 5.3. Same procedure. I got a trinomial. I need to factor this. I have 24x squared minus 20x minus 16. So this is a big one, right? And we learned that you have to take the a times c values. These are some big values. This does happen sometimes, and you got to fight your way through it. The one thing you can do to make your life easier sometimes is look for, can I factor a number out of this first? Do 24x squared, 20x, and 16 have any common factors? Well, if you look at this carefully, I'm going to see that yes, they do. In fact, I could simplify by dividing 4 out of all of these. So I can make my life easier by turning this into 4 times 6x squared minus 5x minus 4. So I took a large question and I've already simplified it. So with doing this, now I can just look at it again. So I got to keep this 4 in brackets. I got to work with this trinomial on its own, and we'll factor through it. So again, real quick here, so I'm going to make my little box. So I'm going to take my a times c box here. So positive negatives are very important. So a times c is going to be 6 times negative 4, which is negative 24. So I need two numbers that multiply to make negative 24, but add to make negative 5. So list my factors. So 1 and 24, 2 and 12, 3 and 8, 4 times 6. Again, 6 times 4, but it's already up there. 8 times 3, it's already up there. So I got all the pieces here. So these two, I need one of these to be positive, one to be negative to make a negative value, and they have to add to make a negative 5. So basically, I need two numbers that are 5 apart. When I say it like that, the 3 and the 8 really stick out. So I'm going to break this 6x squared minus 5x minus 4 into an 8x and a 3x. Which one's going to get the negative? Well, of course, the 8 is, because I need a negative 8x plus 3x. So I still have the 4 on the outside here. I still have a 6x squared. I'm going to say minus 8x plus 3x minus 4. So now the trinomial in the middle, I've broken into chunks, and now I just proceed with normalize those. So I'm going to take a look at the front two pairs, the last two pairs. I'm going to factor both of those. If I factor properly, I should be left with the same pieces. So real quick here, so 4 times 6x squared negative 8x, of course, is going to be 2x will be what I can pull out. So that would be 3x and minus 4. I already have a 3x minus 4, and as it turns out, there doesn't appear to be any greatest common factor here. There's always a greatest common factor, and sometimes that greatest common factor is 1. We do still have to show that it's going to have to be a 1 times 3x minus 4, but at least we do have the same pieces here, the 3x minus 4, the 3x minus 4. Now I can combine that together, so this is still going to be 4 times. So the 2x plus 1 can come together, and the 3x minus 4's stay. And I have successfully completed that. And again, by factoring out the 4 first, I made this a much more easy question to deal with. All right, so a couple more quick examples here, and we will go from there. All right, so the last couple questions here, 3 and 4. So again, these are the ones with shortcuts. These are the ones that some people teach first. I find better to teach last. So the only difference here is I have an a value which is equal to 1. When I see that I have an a value that is equal to 1, so just an x squared standing alone, I can take the shortcut. And I'm not going to explain too much, just in an effort to attempt to shorten the video to explain why it works. I'm going to say just multiply it through and see for yourself why it works. But basically I'm still following the same rules, right? I still have an x squared plus 4x minus 12. I still want to do this whole a times c value, so I need negative 12. I need 2 numbers that multiply to make negative 12, but add to make plus 4. So I'm going to find my factors of 12 are 1 and 12, 2 and 6, 3 and 4, 4 and 3. Oh, I still got them, so I know I got all my factors. So 2 numbers that multiply to make a negative 12, but add to make positive 4. So again, 1 has to be positive, 1 has to be negative. So as it turns out, if I have a plus 6 and a minus 2, that fits my bill. But because my a value is 1, I could use both of those as my factors, and I can just say, well, x minus 2 times x plus 6. It's just the way things factor out. If your a value is 1, we don't need to do those extra steps in between. We don't need to break it into 2 pieces, factor everything out, because it works out every time. Again, so if you don't believe me, take x minus 2 times x plus 6, stretch it out, write it, and see what happens. But if your a value is equal to 1, I'm going to say now the shortcut is take those 2 factors. That is your answer. Here we have 3x squared minus 24x plus 45. So again, there's a big, huge, complicated thing we can do here is I can take, well, the 3 and the 45. So 3 times 45 is 90, 135. So I need 2 numbers that multiply to make 135, but add to make negative 24. Wow, I even bored myself just listening to that. But if you're careful and you watch out for this, you're going to see something might show up. I got 3x squared minus 24x plus 45. All of these numbers are divisible by 3. There's a greatest common factor I can pull out first. And if I take out the 3, I'm now going to be in an a equals 1 situation, which means I can follow a shortcut. So I can sit there and say, well, maybe I don't need all this big number calculation. I'm just going to say, well, this is the same as 3 times x squared minus 8x plus 15. I should write this a little lower. I will write this a little 3x just to give myself room for. Right, so now I have a trinomial in the brackets, which I got a factor, but the a value is equal to 1, so I don't have to go through all the steps. I can use the shortcut method. So again, this times this is 15. I need 2 numbers that multiply to make positive 15, but they have to add to make negative 8. Let's see if this makes sense by writing my factors, right? So I got 1 and 15, and I got 3 and 5, and that's it. Well, how do I get multiplied to make a positive value? It's got to be a positive times a positive, or a negative times a negative. The fact that they have to add to make negative 8x tells me both numbers have to be negative, which if the negative 3 and negative 5 works. So negative 3 times negative 5 is plus 15, and they add to make negative 8. because my a value is 1, I can just turn this into 3 times x minus 3 times x minus 5. And there we go, shortcut. Makes some of these questions that look huge and complex, they can come up and be quick and easy now. So that is going to be our quick look at factoring trinomials. So we just got some special cases to look at, and then we'll be done this lesson. Okay, again, for the shortcut version of the final lesson here, I'm not going to go through everything. There's two cases they look at. They look at perfect squares, and they look at the difference of squares. I'm going to ignore the perfect squares because you can treat those as normal. We can learn more about those next year when we get back together again. But when you're dealing with something that's perfect, so you factor it the same way we factored everything else. You'll see like an x squared plus 8x plus 16. You follow all the same rules. You're going to see it's x plus 4 times x plus 4. And then you end up with just, well, that's x plus 4 squared. So there's no real help to us at this point in time. There helps with shortcuts in the future, and again, I can work you through that later. The other one that does actually show up a lot, and we want to be careful and mindful of this, is going to be the difference of squares. So that's going to be the focus of this lesson here. So the first example is going to take a minute. The next two we're going to fly through real quick, and we're just going to see what is the rule, why does it work. So here we have x squared minus 16x, and I need to factor this. Oops, this is supposed to be just minus 16, so let's just fix that now. X squared minus 16. So what happens here is I have an ax squared plus bx plus c format, but there is no b value. If there is no b value, literally it's that. I can rewrite this as x squared plus 0x minus 16. And I can treat this the same way as any other question I've done before, where I can take the x and the negative 16, and I need the factors are 1 and 16, 2 and 8, or 4 and 4. Well, I need two numbers that multiply to make negative 16, but add to make 0. So that's going to be, the number has to be the same in opposite values, right? Positive and negative. So 1 and 16 won't get me back to 0, 2 and 8 won't get back to 0. 4 and 4 will get me back to 0 if 1 is a positive and 1 is a negative, and they also multiply to give me the negative 16. Because of that, this becomes x plus 4 times x minus 4. And basically we can just use that as another possible shortcut. So, oh, I dropped my marker there. So what we're looking at here is for a question like this, and I'm going to erase this and just start from scratch. When we see x squared minus 16, what can we do with this? Well, all we have to look at to make sure this works with all the rules. So again, this is called a difference of squares. And again, I'm going to use this term lots in grade 11. And it's just that. Is x squared a perfect square? Yes. Is 16 a perfect square? Yes. What is another name for subtraction? It's finding the difference. So is x squared minus 16, is that finding the difference of two perfect squares? It's right in the name. Yes. So when we see this, we can say, well, all we got to do is find the square root of the first one, the square root of the second one, and then I got to do the same thing but with the opposite. So the square root of the first one, subtract the square root of the second one, x plus 4 times x minus 4. This is a very commonly seen difference of squares example. Yes, you got to realize that x squared is a perfect square, x times x. 1 is a perfect square, 1 times 1, right? So x plus 1 will get me the x squared, but I also need the x minus 1 to get me that negative 1 when I multiply them, and the b value will disappear because I'll have a plus x and a minus x. Then they like to throw complex questions with us, at us with this, but again, we follow the same rules. So we're going to say 25x squared, is that a perfect square? Yes, it is, 5x. Is negative 49, or sorry, is 49y squared a perfect square? Yes, it is, 7y. Because it's a perfect square, subtract a perfect square, it is a difference of squares. So the square root of the first value plus the square root of the second value. And we're going to multiply this by the square root of the first value times the square root of the second value, but subtract subtract the square root of the second value. So that becomes 5x plus 7y times 5x minus 7y. And that is your special case trinomials. That is your difference of squares. All right, so painful video, nice and long. Hopefully you just watched in chunks and got the pieces you need. If you do need further instruction, me to go over any of these more slowly or more precisely or more examples, please again, make sure you contact me and I will do just that. All right, good factoring.